Hello everyone. In this video we're going to talk about static routing. It's another video about static routing, and I'm going to include the default static routing. So first of all, what we have routers. So let's first start identifying router devices. We have one router, RTR1, RTA, RTB, RTC, and RTD. So let's say this router here is a headquarter router, or let's say a hub router, and these routers are spoke routers. So we look at routers. So each router, we see how many networks are directly connected. For example, RTR1 has two LAN interfaces, two fast Ethernet interfaces, and 5 serial interfaces. Serial interface mean one links, and two fast Ethernet, which means LAN connections or LAN networks. Now we're going to look at the network addresses assigned to each local area network. We have this LAN with 192.168.10.0/24. The LAN in green color 192.168.20.0/24. This LAN here in the SPOC networks, we have 172.30.100/26. The other one 172.30.10.64/26. This one 172.30.128/26 and 172.31.0.192/26. So it's obvious here that we took 172.31 and we subnet this network address by borrowing 2 bits, by borrowing this bits, certain number of bits from the host address, and we are able now to generate 4 different addresses. Actually, it looks like we started from /24 subnet mask, and we borrow 2 bits from the host address. 24 plus 2 is equal to 26, and then we subnet to generate 4 different subnet addresses. Now each subnet address will go to a LAN, and we use the subnet address to assign IP address to devices inside the LAN. In each one of these networks, each one of these networks is populated with a single host. Now, the purpose of this small exercise is to use static routing and default static routes. Let me just change here, default static routing, in order to achieve connectivity between all these networks and devices. First, we check the IP address assignment. As you notice here, we have the IP address and default gateway assigned to host 1. Host 2 also, it has its own IP address default gateway. The PC1, it has its IP address default gateway. PC2 also, PC3, and PC4. So each computer has been assigned with its IP address and default gateway. Now let's go to the routers. RTR1. RTR1 has 2 fast Ethernet interfaces with IP addresses, and the remaining serial interfaces have been assigned with their IP address. Same thing, RTA, one fast Ethernet interface is assigned with an IP address. Serial 000 also assigned with an IP address. Same thing with RTB, okay, RTC, and RTD at the end. So what is missing now? If we go to RTR1, let me just increase the window size. Now here, if I try to display the configuration file, running configuration, there is no routing. So I can do this. I can do show run and I can include a statement. I would like to display a statement which includes the word route, and there is no such thing. So what I will do now, I will start working with RTR1. I go to the global configuration mode, and while I am in this mode, I will start configuring my static routes to every networks on the other side. So IP route, I specify the network address, or let's say subnet address of the remote network 172.30.100. The subnet mask should be written in the dotted quad decimal notation, which is 255.255.255.192. And in order for RTR1 to forward the packet to this network, to send the packet to this network, it should forward it to this IP address 10.0.0.2. So I'm going to put this next hop IP address 10.0.0.2. Right, this is for the first network. Let's go now to the second one. So the second network here is 172.31.0.64. This is what I will do. 172.31.0.64, and I will put now it will have a different next hop IP address 10.0.0.6. So I will change this one. I will edit it and put 0.6. Now I will go to the third network, which is 172.31.0.128. Okay, 0.128, why not 128, and the next hop IP address for this network is 10.0.0.10. Okay, I'll just have to change this 10. And the last network here is network 172.31.0.192. So what I will do, I will change the subnet address to 192, and the next hop IP address will be 10.0.0.14. Okay, so now I'm done with that. We have the internet. So on the internet we have a server here. So I just simulated a server 196.15.60.1, and normally internet is much bigger than that. So what I do, instead of specifying particular network address for the internet, I'm going to use the default static route. In the default static route consists of writing this notation 0000, any network and any subnet mask. Okay, and the next hop IP address will be 10.0.0.18. This is the next hop IP address to reach the any server on the internet. So I don't have, because the internet is large here, I'm just simulating with a single server, but in real life is much larger. We have hundreds of thousands of networks, so it's out of question to populate my routing table with an entry to every possible network on the internet. So instead I'm going to use a default static route. Where here you put 0.0.0.0, which means any network, and a subnet mask also. It can fit any possible IP address in the IP address, any bits in the IP address, or any combination of bits in the IP address. So the next hop IP address will be 10.0.0.18. So I'm done now with my with configuring RTR1. I just display the routing table, show IP. Okay, I do this, show IP route. Now if I want to be specific, I can type show IP route static, then I will display only static entries configured on RTR1. So we have how many static entries? 1, 2, 3, 4, plus the default static route which goes to the internet. Now I'm done with RTR1. I will go to RTA. Now what I will do with RTA, I'm going to configure this router to reach these two networks specifically, and also to reach any one of these networks. So what it means that if I configure the RTA with static routes, I have to put this number of static routes. One static route to point to this network, another static route to point to this network. So we have 2 static routes, another static route to point to this network, so 3, another one to point to this network, 4, another one to this network, 5. So, or 6. So we're going to have 1, 2, yeah, 5. So 1, 2, 3, 4, and 5 networks. So is it worth doing all this effort? So maybe it's better to put the default static routes. So instead of populating my Spock routers with route to every possible network, so I just going to configure a default static route. It's much better, because I know that the details are configured are inside the RTR1. So let me just go to RTA. Okay, do we have any commands that include the word route? No. So we don't have any configuration regarding routing. So what I do now, I go to the global configuration mode, and from here I will configure my default static route. So each time RTA receives a packet to destination any network, just forward it to this next hop IP address, which is 10.0.0.1. As simple as that. Right. That's it. So now let's go back and check the routing table. So we have only single static route, and you see the star here, it means candidate default. So this is our default route. So whenever there is no specific information about a remote network, this route is going to be used by a router to forward the packet to this IP address. So this IP address is an IP address of a router, and then it will be the responsibility of this router to forward the packet to destination. And since RTR1 knows how to reach any one of these networks, so it will not be a problem. Now let's go to RTB. Same thing in RTB. I'm going to configure a default static route. So the first thing here, let's check if there is any command which contain the word route. So routing is not configured. Now let's go to the global configuration mode, and from here I will configure my default static route. Any packet, a packet sent to any network, it will simply be forwarded to 10.005. As simple as that. Now let's check our routing table. So we have a single default static route in our routing table. Now let's go to RTC. RTC also is very simple. We go to command line interface, check if there is any command with the word route. There is no such thing, so I go directly and configure and put static route in my routing table, IP route 000, and whenever RTC receives a packet destined to any network, it should simply forward it to the next hop IP address 10.0.0.9. This is what we want. Okay, now let's check our static route. Good. Now let's go to the last router, RTD. And RTD, actually, we're going to do something like this: IP route, and configure the default static route and forward it to 10.0, this IP address 10.0.0.13. And then here I'm going to display my routing table, only the static route in my routing table, and this is what I find. Of course, I can do similar thing. I can go to the internet, and of course, if instead of configuring all the route to all specific network, or let's say static route to specific network, I can go here also and configure a default route to reach this, to forward the packet to this destination IP address 10.0.0.17. So I will do that. So okay, IP route 000 10.0.0.17. So everything now is there. So let's check the routing table. So IP route static. Okay, so we have now a single default route. Now let's go to host 1, and I'm going to use host 1 actually from there. I'm going to check if there is connectivity to any one of these networks. For example, from host 1, I'm going to trace route to host 2. I will specify the IP address of host 2, 192.168.20.1, and let's see if this works. So this is the default gateway, 192.168.10.250, and this is the target. Okay, it works very good because they are directly connected actually. Now let's trace route to something more serious, which is a remote network. Here we have 172.31.0.1. So this is the IP address of PC1. Now let's see if it works. So this is the default gateway. Then the next IP address is the IP address of RTA, and the target is the IP address of PC1 itself. So everything is working fine. Now let's go to this host PC2. So the IP address is here. It ends with 65. So now when I use 65, because it's different subnetworks, it means that I am talking to a different network. So you see, trace route is working fine. Now let me trace route to 129. 129. Everything is working fine. So this is my default gateway. This is the IP address of the next hop IP address of the router, which is 10.0010, and this is the target. Now let's trace route to let me trace route to the last one, which is 193. Okay, it looks like it works fine. So this is the next hop IP address, the second router in the path, and finally the target itself. Now let's do some testing from, okay, I can always do something from host 2, why not? I can change. I go to the internet. This is IP address 196.15.60.1. So let me just trace route to that. 196.15.60.1. So this is the next hop IP address 10.00.18, which is the IP address of routers on the internet, and finally the target itself. So everybody is replying. So I can access that server on the internet by just putting its IP address 196.15.60.1, and here it is. This is the web page of if that server is acting as a web server. Now I can also test from PC2. Okay, since I test from host 1 to PC2, normally it should work, but let me see from PC2 if I can reach other PCs. First, I will do trace routes, because trace route is the best command to use in order to check connectivity across routers. So from here, I first, let's say, trace route to host 192.168.10.1. Is it working? Yes, everything works fine. Now let's use the host 20, which is host 2, second host. So second host is working fine. Now the moment of truth, let me try to trace route from PC2 to PC1. So PC1, it means I have to put IP address 172.31.0.1. Excellent. So it works fine. And you notice here how many routers. You have the default gateway of PC2, which is RTB. This is its IP address 172.31.0.126. Then this is the next IP address 10.0.0.5, which is IP address of the second router. Now this is the IP address 10.0.0.2 is the IP address of the third router, and finally the target itself, which means that in order for PC2 to reach PC1, it has to cross 1, 2, 3 routers. And now let's try to reach PC3 129. Okay, it works fine, very good. And finally 193, and it works fine also. We have 3 routers in between. So as you notice here, what I use the specific static routes or static routes to specific networks, and also I relied on a default static routes. And the default static routes, basically when a router receives a packet, it does not have a specific entry about destination network. Then it will resort to the gateway. It will use the gateway of last resort, which consists of using the default route, and hopefully the next hop IP address is the IP address of the next router, which might have the details how to reach the destination.